Okay, guys, welcome back. I hope you guys had a great vacation. I really do mean that. Today, we're going to transition from functions to actual linear equations. And if you remember, a function is a relation where there is only one particular y value for any given x value. And remember that a relation is a set of ordered pairs. All right, so remember that a relation is like, this is a relation. 3, 5, 2, 1, 6, 8, 4, -3. That's a relation, any set of ordered pairs. If I only have one y for any given x, then that is a function. So in this case, this would be a function because I do not have repeating y's for the same x. So we're transitioning from that into linear functions for chapter 5. It is a function, that's why it's a linear function, but it's linear. We had talked a little bit about linear as well. We had said that linear means it is a straight line, okay? A straight line. And this straight line can be horizontal or slanted, either going up or down from left to right. And this slant, this angling of the line, the way the line tilts, that's called the rate of change or the slope, okay? That's the rate of change or the slope. The difference between the rate of change and slope is simply that rate of change uses actual units. And we'll talk about that in a second. Now, when we're thinking of a slope, guys, think about ski slopes. Think about it. Hey, we're going to go hit the slopes. They didn't just say that word slopes just because it sounded cool. They used the word slopes because in a mountain, okay, you're skiing down this path, right? That's a slope. It is a line that has been tilted, angled, okay? There is an angle to it. That is a slope. You're going down, that's a slope. When you go upstairs, okay? When you go upstairs in a house or in a building, wherever, you're going up. When you connect all these dots, that's a straight line. And that stairs, those stairs, had a slope, okay? So a slope, or the rate of change, is the ratio of the vertical change. That's the change in the dependent variable. Who is the dependent variable again? X or Y? Dependent is Y. Very good. So it's the ratio of the vertical change over the horizontal change, which is the change in the independent variable X. So slope, or rate of change, is the change in the Y values divided by the change in the X values. It is the horizontal change divided by the vertical change divided by the horizontal change. The change in Y divided by the change in X. The only difference between slope and rate of change is that rate of change actually involves units. Now, as always, there's a formula for this. Okay? And slope equals the rise over run or a fall over a run. When the slope is positive, gentlemen, I'm going to rise. I'm going to go up from a particular point. And I'll talk to you later. We'll discuss how to graph all of this, I promise. But right now, if the slope is positive, I'm going to rise up from left to right. Whenever we're dealing with reading a linear equation, or any function for that matter, we're always going from left to right. Left to right. So when I'm going up from left to right, I have a positive slope. Going up, so it's a rise. When I have a negative slope, I'm going down from left to right. That is why I call it a fall. So the slope is a rise over run or a fall over run. If it's positive, I'm going to rise. Okay? So that means I'm going up from left to right. When I have a negative slope, a fall, that means I'm going down from left to right. Does that make sense so far, everybody? Okay, now, slope is represented by a lowercase m, as in Mary. And this m, which is the slope, equals the value of the second y minus the first y divided by the value of the second x divided by the first x. Okay? It's going to be y2 minus y1 over x2 minus x1. Now, where is this coming from? Well, my x1 and my y1 is the first point. Any other point to the right of that is x2, y2. x2, comma y2 is any other point on the line. Okay? So again, you rise with the slope if it's positive. You fall with the slope if it's negative. The run is always constant though. You always run to the right. You always run to the right, unless you're going backwards. And we'll talk about that in a second. Now, when you have a line, and this line, of course, you determine the slope or the rate of change, please be aware of the fact that the slope or the rate of change of a particular line is constant throughout its own linear equation or function. So when I have if I say the slope of this line is 6, that means from any point to any other point, you're going to follow the slope of 6 over 1, 6 over 1, 6 over 1. Slope or rate of change of a linear equation or function is always constant. The slope cannot change in the middle of the line. Okay? So lines, linear equations or linear functions have constant slopes. Their slope does not change. Now, let's talk about an example. Let's go ahead and find the rate of change. Notice in parentheses I put here, please remember that the rate of change is the same as the slope, except it includes units of measurements. So what we do here is, okay, my first point, isn't this my first point here? Yeah. So I'm going to call this, I like to label things. That's my x1, that's y1. Any of these other points can be called x2, y2. Which ones do you guys want to choose? Because I don't care. Okay? So this is x2, y2. So first thing, whenever you're given a relation or a set of ordered pairs, first label your x1, y1, x2, y2. It doesn't really matter who you choose. Does this make sense though, so far? Now remember, my brothers, that slope equals y2 minus y1 over x2 minus x1. So let's plug in the formula. y2, 520, minus y1 of 260 over x2 of 2 minus x1 of 1. 520 minus 260 is 260 over 1. However, this is a rate of change. Notice how you had units? So what does this really mean? This means that you traveled 260 feet in 1 minute. If you have units, you're looking for a rate of change. If you do not have units, you're simply looking for your slope. Slope and the rate of change are exactly the same. The rate of change is simply the slope with given units of measurement. Does everyone see what happened here, how this happened? Does that make sense, guys? y2 minus y1 over x2 minus x1. Is everyone with me so far? Okay. Now, says, remember to always find the independent and dependent variables first. Then label your x1 and y1, and then your x2 and y2. In this case, time is x, and distance is y. Time, as we know, is always independent. So whenever you're given a rate of change, or a slope calculation, whenever you're given a rate of change or slope calculation, all right, you first got to determine your independent x and your dependent y. In this particular case, once again, time is independent, so time is x. Distance, it depends on how long you were traveling, so that's why it's dependent. Does that make sense so far? All right, so let us continue, my brothers. Now, there are 4 kinds of slopes, guys. 4 kinds of slopes. Okay? The first 3 are all linear because they are valid. They have slopes that are valid. Bless you. A positive slope. Check it out, guys. Remember how when I said when you have a rise of a run, you're going up from left to right? That's what a positive slope is. Look at it. Goes up from left to right. Remember, always read from left to right. Always read from left to right. A negative slope, from left to right, it goes down. A zero slope is a y equals equation, and that just goes through the y value. It never touches x. When it has a zero slope, it never touches x. It's a horizontal value. Horizontal slope means that that line is going through that y value forever, never hitting the x. And then you have an undefined slope. Now, this is very tricky. This is a straight line. Yes, it is. Yes, it is. Most people will say, but that's linear, Mr. Morrow. No, it's not. Why is it not linear? Very good. Thank you so much. That's awesome. My boy just said, well, if you do the vertical line test here, at this x value, you have this y and 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 this y. So when you do the vertical line test, it fails. You have different y values for the same x. That's impossible. So although this slope is valid, that's an undefined slope. This is an x equals equation, and we'll get into that later. This is not linear. This is not linear. That is an undefined slope, yes. But it's not linear because it's undefined. It's not a function. Okay? So 4 types of slope. If my line is going up from left to right, I have a positive slope, a rise over run. If my slope is going down from left to right, I have a negative. That's a fall over run. If I have a straight horizontal line going through one particular y value, that's a zero slope. And if I have one line going through one particular x value, that's an undefined slope. Okay? Does that make sense? Yes. Okay, now, something about undefined and zero slope as well. Just so you can see what happens here. Let's say I choose this point and this point. This first point here is 1, 2, 3, 4, 5, 1, 2, 3, 4. So this is negative 5, 4. That's my x1, y1. And this one is 1, 2, 3, 4, 1, 2, 3. So this is 4, 4. That's my x2, y2. Check it out. y2 minus y1 over x2 minus x1. When you have a zero slope, it's going to be 0 divided by a number. Whenever you have 0 divided by a number, 0 divided by anything is 0. That's why it's a zero slope. If we do the same formula over here and we test why is this undefined, let's check these points out. This guy, and let's do this guy. This is 1, 2, 3, 4, 5. So 5. So this is 5, 3, which I'm going to call my x1 and y1. And this is 5, 5, negative 3, which I'm going to call x2, y2. So y2 minus y1 over x2 minus x1. Look what happens. I got negative 6 over 0. You cannot have 0 in the denominator. That's why it becomes undefined. So if you just see the graph, you can just know, okay, this straight line going through an x is undefined. But if I give you these point values, don't stress out when you see a 0 in the denominator, my brothers. If you see a 0 in the denominator, it's undefined. Done. If you see a 0 in the numerator, the answer is 0. Done. 0 slope, undefined slope. Does that make sense? Thank you. Okay. Okay, now, what is the slope of each of the given? Okay, there's a couple ways to do this. I see a bunch of hands raising. Good. What were you going to say, my brother? Okay, yes, that's the kind of slope it is. It is positive. Good man. But it says, what is the actual slope? How would you do it?
Rise over run.
Yeah, you're going to do rise over run. Well, in this case, you got two choices, though, my brother. Let me show you how cool this is, all right? In fact, let me show you. Let's see if I can make some magic happen today. Let's see. Okay, let's look at my magic pen. And let's take a look at this particular section. Okay? Let's look at what happens here. My brothers, look at what's happening from this point right here to this point over here. Am I not going up 1, 2 over 1, 2, 3 to the right? Do you guys see that? I'm going up 1, 2 over 1, 2, 3 to the right. Do you guys see that? That's my rise over run. That's my slope. So I could have done it two ways for this. I could first know that's my first point. I got to go up 1, 2. So I went up 2, and then I went to the right 1, 2, 3. So my rise over run, that would be 2/3. So that's one way to do it if you see the actual line. Does that make sense? Second way to do it, actually plot the points. This point here is -2, -1, because I have a point right there. But what do you mean it's not labeled? All of these go by ones unless I label it. Thank you for asking. It's a great question, son. All of these are going to be by 1. When you have your graph paper, guys, whenever you make a graph, your labels are always going to be 1. Your values are going to be 1 unless you change it. If you change it, then I need to see it. So, for example, if you're going by 2s, I need to see 2, 4, 6, 8. If you're going by 3s, I need to see 3, 6, 9, all that good stuff. Does that make sense? Yeah? Okay. I was still on magic pen, sorry. Okay, so does that make sense? Okay. So this point here, like I said, is -2, -1. This point over here is 1, 1. So this is my x1, y1, x2, y2. y2 minus y1, so that's a positive, over x2 minus x1, so that's going to be 2/3. They better work out the same. Yes, sir.
What do you do after you get to 2/3?
That's it. That's your slope. That is your slope. Slope of this line is up 2 for every 3. So look, maybe this will help you guys out. I don't think you guys are understanding the slope yet. Look, from any given point, for example, this is a perfect point here. A perfect point, guys, is this right here in the center. This guy right here in the center. Let me do a little magic pen on that again. Think about when you guys are playing all those little video games that I love so much. I'm being sarcastic. Don't you have to shoot the guy at the bullseye? The bullseye is right there, guys. That's the bullseye. That's a point. The bullseye is where the crosshairs meet. Are you with me?
Yes.
Okay. So then on that note, okay, that's a perfect point. So you choose a perfect point. And you're, okay, from this perfect point to this next perfect point, what did I do? Well, I went up 1, 2 over 1, 2, 3. From this point to this perfect point, what did I do? I went up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Forever, you will follow this slope of up 2 over 3, up 2 over 3, up 2 over 3. Does that make sense? You sure, my brother? Thank you. Does this make sense, guys, before I move on? Sir?
Can you solve it again?
Y2? Sure I can. So basically, we got to choose some perfect points. So the first perfect point I chose was this right here, which is -2, comma, -1. The next perfect point is right here. That's a perfect point. It's 1, 2, 3, 4 over 1, 2, 3. So that's 4, 3. X1, Y1, X2, Y2. Y2 minus Y1 over X2 minus X1. That's going to be 4 over 6, which is 2/3, sir. Sir. Yes, the question was, do I have to choose perfect points? Yes. If you chose this point right here, that's, how are you going to estimate that? Do you see what I'm saying? That point right there, I'll do it in red so you can see what I'm talking about. This point right here, is that a perfect point? Is that at the crosshairs? So that's an estimate. That's like 2, comma 1.5 or 1.6. You can't do that. You have to have perfect points so you can get perfect answers. Thank you, son. Does that make sense so far, my brothers? All right, now, let's go ahead. And this next one, okay, I have a point here, and I have a point here. First of all, is this going to be negative or positive? That's exactly right, because it's pointing down from left to right. So I have two choices here. I was given a graph, so whenever I'm given a graph, I have two choices. Me, I'm going to do it the easy way. From this perfect point to this perfect point, I went down 1, 2, 3, 4. So down 4, -4, over 1, 2, 3, 4, 5, over 5. So my slope is -4/5. To get to the next point, you would go down 4 over 5. So you'd go down 1, 2, 3, 4, over 1, 2, 3, 4, 5. And continue forever. Does that make sense, guys? Okay, now, let's say that I didn't want to do it that way. For whatever reason, you were nervous, you didn't want to do it that way. You want to do it the long way. So, okay, that's fine. Pick your points. This is going to be 1, 2, 3. So this is going to be -3, 2. This over here is going to be 2, comma, -2. X1, Y1, X2, Y2. Y2 minus Y1 over X2 minus X1. We've got -4/5, same as before. Does that make sense, everybody? Promise? All right, awesome. Okay, let's see. Who wants it? Let's go. Come on. See if you can hook up this slope. You can do it either way you want. I would suggest just do it the easy way. No, it doesn't matter what marker, Papa. Thank you. Okay, that's completely wrong. With all due respect. -3. Good boy. Good. I'm glad you made that first mistake. Awesome. Good job. So that makes sense, everybody. It's negative because it's going down from left to right. That's why I teach you when it's positive or negative. And he went down 1, 2, 3. And I ran to the right. You always run to the right, 2. You always run to the right unless going backwards. Does that make sense, everybody? Yes, sir. Come on up. Come on up, Buttercup. Do it. Yeah, you know, it's a new year. We got to start happy. Correct? Yes. I know you got the count right. There you go. Bless you. Done. Awesome. Positive, up 2 over 3. Now look, if I want to continue this slope, check it out. Up 2 over 3, perfect point. Up 2 over 3, perfect point. Up 2 over 3, perfect point. The slope is constant in a line. Does that make sense, Papa? Sure? Okay. Okay, these are easy. What's the slope of this bad boy? Undefined. Very good. Very good. See how easy it is once you learn it? And what's the slope of this bad boy over here? That's a 0 slope. Heck yes. Well done. Well done. Does that make sense so far? We're doing great. Yes, sir. Okay, how do you tell the difference between undefined and zero? Go ahead.
0 makes a horizontal.
0 is going to be a horizontal line,
And 5 can be a vertical.
and a vertical line is going to be undefined. Or you could do it the long way, which is what I taught you, Papo. Let's say I choose a perfect point here and here, okay? 1, 2, 3, 4, 5, 6. So this is negative 6, 3. This is going to be negative 6, negative 2. x1, y1, x2, y2. y2 minus y1 over x2 minus x1 is going to give me negative 5 over 0. I cannot have a 0 in the denominator. It's undefined. But it's a lot easier and a lot quicker and a lot better and a lot more efficient. You could just learn a vertical line goes to the x-axis only. It never touches the y. It's vertical. It's an undefined slope. Zero slope is going to be a horizontal line. Or you can actually do the math as well, my brother. Okay? It's not going to hurt me at all. Thank you. Just take more time away from you later on. Does that make sense? Great question. Thank you. We're good? All right. Now, just a little reminder. Slope equals m. Remember that. We're going to be talking about m here very shortly in a couple sections. And m equals y2 minus y1 over x2 minus x1. Remember, it's slope. Slope is the vertical change divided by the horizontal change, or the change in y value divided by the change in x value. So, let's check it out. I want to find the slope that passes through these given points. Label, 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 and then put it in the formula. x1, y1. x2, y2. y2 minus y1 over x2 minus x1. Look at what I did there, guys. It's minus the value of x1. A lot of people will just put minus 3 there, and that is wrong. It is x2 minus the value of x1. So this is negative 3 over 1. So my slope is negative 3 over 1. Well done. B, x1, y1, x2, y2. Pay attention to this one because this is a little trick. y2 minus y1 over x2 minus x1. Wait a second, that's 0 over negative 7. What kind of a slope is that? Zero slope. Now, here's the trick. Guys, did any of you notice that the y values were the same? Well, guess what? When the y values are the same, two things should enter your head. First of all, the y values are the same, I have a zero slope. Secondly, didn't we just say that whenever we have a zero slope, it's a line that's going horizontal to a particular y value? What y value is it going through in this case? 1. So this equation would look like this. Here's 1. It would look like that, right? Does it ever hit x? So the equation for this, we're going a little bit ahead, but this is just so easy. The equation would be y equals 1. Whenever you have a zero slope, the equation of that line is y equals the y value that it is actually going through. So here I had 3, 1 and negative 4, 1. Oh, wait a second. The y's are the same. Slope is 0. Oh, wait a second. The y's are the same. The equation is y equals that value. Does that make sense? Hello? Okay. Let us continue. Now look at what happens here, guys. Which ones are equal here? So what's the slope going to be? What's the equation going to be? No, in this case it's an x equals, right? Because in this case, here's the 7, and it's going down this way, right? So x would equal 7 here. So even though we haven't talked about equations, and I promise we will revisit that again, right now you know some really powerful information. If the slope is 0, that means it's a horizontal line going through a particular y value. The equation of that line is y equals that value. When the x values are the same, you know you have an undefined slope. It's a vertical line going through that particular x value, So the equation is going to be x equals that particular value. Does that make sense, guys? Okay. Now the rest of these, pretty simple. Let's see if we can figure these out, even though there's fractions. X1, Y1, that's why I told you got to be masters of fractions. So Y2 minus Y1, I'm going to put a denominator of 1, over X2 minus X1. Okay, common denominator between the numerator is 3. So that goes to 3, that goes to 9. So that's negative 8/3. Divided by, that goes to 5, that goes to negative 20. Negative 22/5. Is everyone with me so far? Is everyone with me so far? Is everyone with me so far? Okay. So now that's going to be stay, change, and flip. And let's go ahead and cross divide a little bit. 2 goes into 8 4 times. 2 goes into 22 11 times. So this is going to be negative 20 30/3. That's the slope. Looks ugly. It is ugly, but that's the slope. If you guys don't know how to add fractions, I suggest strongly you look at my videos or find some other videos or, get some help. Please. But it's the same formula, right? Okay, let's see if you guys are paying attention. What's the slope here for E? Slope is undefined. Just for giggles, what's the equation? Haha, very good. Very good. Yes, sir, my brother. Excuse me. What, Papa?
Isn't it like 2 negatives equals positive?
When you're multiplying 2 negatives. Yeah, but here you're adding negatives. Negative 20.
But when you do the dividing part.
State change. Oh, that's right. This is a negative here. I was not paying attention. Thank you, son. There's no excuse there. Thank you, son. How about for F, guys? Do I see anything that's the same here? Okay, so what's my slope? No, my slope. My slope. My zero slope. My equation? Y equals negative 3. Does that make sense, my brothers? Awesome. Awesome. And we are done. Great job, guys. I'm going to go ahead and close this out, and then we'll do some practice problems. Thank you very much. God bless you.